Hello everyone, this is Darren with Renaissance Coders, and I'd like to remind you that if you learned something in this video, go ahead and drop a like for us. But I'm going to be teaching you how to add jumping functionality to your character controller, and we're also going to focus on tidying up our character controller from the last tutorial. Now, the reason we want to organize things is because as these tutorials progress, we're going to be adding more and more functionality, and we want to be sure that we maintain the readability of our scripts. All right, so let's go ahead and jump into it to see what it is we're going to need to do to get our character jumping. All right, the first thing we want to make sure is that we add a collider of some sort to our character. So I added a capsule collider just because it fits best on my character. It fits the shape nicely. Now, the one thing you want to make sure is that your whatever collider you use, you want to make sure that the bottom of your collider comes below the origin of your character. So right here where the arrows are, that's going to be the origin of my character, and you can see that from the green lines, the collider comes down just below the origin. So that's the only thing you guys need to make sure. Now, these are the settings I use for my capsule collider. They're going to be different for yours because most origins are going to be towards the center of the character, but you guys can go ahead and play around with that until it fits your character nicely. Now, as a reminder, with the rigid body, we want to make sure our gravity is unchecked because we're going to be modifying gravity manually from our script, from our character controller. And the reason we do this is so that we can have more control over how our character moves. And then finally, make sure that you freeze the rotation on your X, Y, and Z axis so that you don't have any sort of stumbling, so that your character is not stumbling over their own collider. Alright, now let's go ahead and go to the script to see what we're going to be doing. As I mentioned before, I want to go ahead and organize things. So I'm going to create three main classes. I'm going to create one for move setting, I'm going to create one for phys settings, and I'm going to create one for input settings. Alright, so let me go ahead and do that. So move settings here. And I'm going to go ahead and just copy and paste this. Now remember, we need system.serializable so that these classes values can be seen from the inspector. Alright, now this one's going to be phys settings, so physics settings there. And then finally input. And then what I'm going to do is I'm going to divvy up these values that I already created in the previous tutorial into these classes. So the velocity stuff is going to go in my move settings. Now phys settings is only going to have one value for now. We may go ahead and extend this class later, but for now we're just going to have this downward acceleration. So we're going to call this down accel. I'm going to set that equal to 0.75. So down accel is just going to be how fast we're going to start moving downwards whenever we're not grounded. All right. Now, before I go ahead and add more stuff to these classes, I want to make sure I remember to create the references to the classes. So I'm going to do it for move settings. Alright, and I need to do this for the three other classes as well, or the two other classes. Alright, and again, this is just going to be sure that the classes can be seen and modified from the inspector. Alright, so once we do that, we can go ahead and start adding these values, the values that we're going to be adding for the jump functionality. Okay, so for move settings, what we want to have is a jump vel. So our jump velocity, I'm going to set that equal to 25. And we're going to have this float called distance to grounded, or dist to grounded. And what this is we're going to be shooting a raycast downward from our character, and it's going to return a distance and a boolean. So the distance is going to be how far from the ground or from our layer mask ground is our character, and if it's within this range, then we're going to return grounded to be true or false. Alright, so basically if our character is 0.1 off of the ground, so 0.1 units off of the ground, then we're going to call it grounded. Now my character's origin is close to the bottom of its collider, so this is going to be a low value for me. If your character's origin is more towards the middle of the collider, then this might be a large value. So if it's somewhere around 0.5 or 0.8, that's fine as well. Now we're going to have one more for our move settings called layer mask. We call this layer mask ground. And what this is each object has a layer in the scene, and what we're going to be able to do is tell our character what specific objects it is able to jump from. All right. Now I want to add some input settings here. I want the user to be able to um, determine what buttons do what from the inspector. Okay, so we're going to have a string for forward axis, and the default of this is vertical. And we're going to have a string for our turn axis. Default for this is horizontal. And one more for our jump axis, so what's going to get our guy jumping. And the default for that is jump, and that's going to be our spacebar. Okay, so I think that's going to cover it for our classes. Let's go ahead and add um, that method that's going to determine if we're grounded or not. So we'll call this bool grounded, and it's going to return a boolean. So physics raycast is what we're going to use, and this actually does return a boolean. And there's a lot of different parameters that we can pass to it. What we're going to be doing is casting an array downwards from the character's position. So let's start off by creating an array. So we'll say transform dot position, and array is just it's an origin with a direction. Okay, so our origin is transform dot position. Our direction is vector3 dot down. So we're going to be casting array downward. Now max distance, that's how far from the ground before we're considered grounded. So that's going to be our move setting dot dist to grounded. And then finally our layer mask. So what objects are ground? So our layer mask setting is called ground. Alright, and that's going to cover our grounded. So this method is going to be what determines if our character is actually grounded, thus allowing us to jump. Now there's one more value I want to add up here called velocity. And the reason I want it is since we're dealing with motion on all axes now, so our x, y, and z, we want to make sure we have this velocity vector to make our movements a lot more easier to manipulate. Alright, so we're going to set this to vector3.0 initially. Alright, so now what we need to do is go ahead, and you'll see these red squigglies now. Since we added these classes, we need to make sure we're using the dot operator now for those classes. So I'm just going to go ahead and add these really quickly. Alright, and now what we need to do is modify our get input method a little bit. So this is going to be input setting dot forward axis. It's going to be input setting dot turn axis. And again, the reason that I do this is so that if we're playing the game and we decide that we want to change the input button for moving forward or turning or jumping or whatever you may want to do, they can do that from the inspector at runtime. So this is just going to optimize runtime changes. Alright, now we need to add a jump input float. I forgot to do that, and initialize it to 0 down here. And now finally in get input we can actually set a value to jump input. So we're going to set this equal to input.getAxis raw input setting dot jump axis. Now why do I use input axis, or why do I use get axis raw? Because we don't care about any interpolated values. If you remember from the previous tutorial, these values are interpolated because we're using get axis, and what that means is it'll return any value from -1 to 1, so it could be 0.1, 0.15, so on and so forth. Now get axis raw is not going to be interpolated. Okay, so what that means is that the only values we're going to get is either -1, 0, or 1. And that's all we really care about with jumping, because our jumping is not going to have any sort of smoothing, as with regards to input, that is. And so we only care if our jump input is greater than 0, because that means that the player pressed the spacebar. Alright, so let's go ahead, and I think at this point we can go ahead and actually code up our jump function. Alright, now we're going to be running the jump method. Alright, let's go ahead and create it first. So we're going to have this jump method down here under our turn method. Call it jump. Alright, there we go. And we're going to be calling this in fixed update. Alright, now get rid of these rBody.velocity lines, because we're not going to be modifying the rigid body velocity directly anymore. If you remember, we created that velocity vector, and so what we're going to be doing is just modifying the axes that we care about depending on our input. And so for forward, if we're running, we only care about our .z component of our velocity vector. So we're going to set that equal to move setting dot forward vel times forward input. All right, so basically it's the same thing, but we're just modifying the .z component, and we're not multiplying by transform.forward because you can't multiply, you can't return a vector3 into a float, which is what we're trying to return. So what we have to do to get our character moving in the correct direction is actually say our body equals transform direction velocity. And actually this is our body.velocity, my bad. Alright, so what I want to do actually is first show you guys why we're using transform direction. Okay, so I'll go ahead and first say velocity equals our body.velocity equals velocity, and you guys will see why we need this line of code instead of this line of code. Alright, but let's go ahead and code up our jump first. So we're going to code up our jump function first. And so what we're going to say is we're going to say if our jump input is greater than 0, so if we're pressing the space button, and grounded is equal to true, okay, we're going to do something here. So here we're going to jump. Alright, else if, so we're going to have this else if jump input is equal to 0. So here we're not pressing the space button, and we're grounded. Okay, so if we're grounded and we're not pressing the space button, we want to make sure we zero out our velocity dot y. Okay, because we don't want to move downwards whenever we're already grounded and we're not pressing jump. And then finally else, so this else is going to be if we're not grounded, so if we're in the air and we're not pressing the button, or we're pressing the button or whatever. So if we're not grounded and we're falling, essentially is what this is going to be. So if we're falling, we want to make sure we decrease velocity dot y. Alright, so let's start off with this jump. Now with jump, all we're going to be doing is saying velocity dot y is equal to move setting dot jump vel. So that's all we have to do there. And then here we're just zeroing out velocity dot y, so equals 0. And then else, so if we're falling, all we're going to be doing is decreasing that value, right? So we say velocity dot y minus equals move, or actually this is going to be phys setting dot down accel, so downward acceleration. And that's all we need to do. So you can see how simplified that was by breaking it up into several if-else statements. And these are going to cover all of the possible situations with jumping. So either we're going to be grounded and pressing the button to jump, or we're going to be grounded and not pressing the button to jump, or we're just going to be not grounded. And this is going to be, now we're going to be decreasing the velocity dot y whether we're pressing the button or not if we're falling and we're not grounded. Okay, because essentially that button isn't going to be doing anything if we're in the air. Alright, so that covers that. Now, that's actually going to finish this script for jumping. Now remember, I want to show you the difference between using transform.direction and just this regular line of code here. Note how we're moving our velocity.forward here, velocity.z. Alright, so this is what we want this to do, is move our character on its own transform.forward. Alright, so let's go ahead and run it to see what it does now. Alright, so you can see that no matter which way I turn, if I press forward, I'm going to go in the global forward direction. Alright, so what I need to do is uncomment that line of code that we had. Alright, so we actually need to say our body.velocity equals transform.transform direction. So we're going to be moving in the transforms direction, and we're going to be passing the velocity vector that way. Alright, so now if we go ahead and run, the first thing we want to make sure we do is set grounded, our ground layer mask to everything. We're going to set it to everything for now. Initially it'll be set to nothing, but again, set it to everything. So what this is saying is that we can jump off of anything. Alright, so if we run this, I'll go ahead and maximize on play. Now what you'll see is that we can actually move in the direction we're facing, and we can actually jump now. Alright, so we have this jumping functionality added. It rises up gradually and it falls at a nice speed. So this looks pretty realistic to me. you can modify those values, the downward acceleration specifically, if you want to fall faster, or the jump velocity if you want to jump up quicker. So let's modify these values a little bit. I'll set the jump velocity to 50, so we're going to jump really fast, but I'm going to increase the downward acceleration, so we're going to be going up to the same height, but we're going to be getting there faster, and we're going to be falling more quickly. Alright, so let's see what this looks like. And these are the two values that you're going to be modifying to get your jumping looking the way you want it to look. Alright, so we're actually jumping a little bit higher. You can see we're going faster, but we're falling faster as well. So if I want to maintain that jump height, I'm just going to modify my downward acceleration. I'll make it a little bit higher now. So 1.75 is quite higher. And there we go. We're getting closer to that jump height that we had originally, and we're falling a lot faster now. Alright guys, so go ahead and play with the jump vel and the downward acceleration values. That's what's going to get your jumping the way you want it to be. But that is going to conclude this tutorial. As always, go ahead and drop a like if you like the video. Go ahead and subscribe to our channel if you're liking these tutorials. But as always, this has been a Renaissance Coder tutorial. Thanks for watching, and we'll see you in the next tutorial.